Thank you. Thank you. So I'd just like to go through a few of the housekeeping items before we kick off the presentation. And just as a reminder, please make sure that you are muted. And if you do not want to have your face seen or be on video, you can also go ahead and turn or select the stop video option in the Zoom, just to let everybody know. So we've had a really, really strong start to our year so far. We've had 4 events, including tonight, that have offered PDH credits, including 2 webinars, our March in-person dinner event, and our trip to the Botanical Gardens in April. So thank you for everybody that attended those and made those successful events. Our June in-person dinner event is scheduled for June 20th, and registration for that should be open now on the website, www.liapg.org. And just to remind everybody, we do typically take off from presentations during the summer, but we are working on some fun of summer events, including the summer canoe/kayaking trip and barbecue, which is scheduled for August 17th. There is a save the date on the website. Registration is not open for that yet, but it will be as it gets closer to that date. And then we also just were able to book a guided tour of the Museum of Natural History's Hall of Gems for July 28th. So that save the date went up today. Again, that will open up for registration as we get closer to the event. So as you can see from our statement here on the presentation, we are open. We are an open organization. We do encourage open participation. We welcome anyone who would like to participate, anybody's input. It does help to keep the content that we try to present here engaging and relevant. So I just wanted to put that out there. I think everybody is probably aware of that. Here's a list of our corporate sponsors. We do have about 15 corporate sponsors currently. If you are a corporate sponsor and you see your logo up here and it's not up to date, please let us know, let me know, let somebody on the board know. Hopefully we haven't missed anybody, but I don't believe that we have. And we do really thank these corporate sponsors. They do support this organization. They keep it going. And in case anybody isn't aware, there are 2 levels of corporate sponsorships. The Topaz sponsorship includes membership for up to 10 employees. And then the Diamond entitles your company unlimited employees as members of the LIAPG. And then some benefits that come with it are discounts on dinner meetings and webinars, and those we typically offer with PDH credits. So here's a list of the presiding officers and board members of the LIAPG. Like I said, we are an open organization. We do meet monthly on the first Wednesday of each month. We can be both in person or via Zoom, depending on people's availability. And all members are welcome to attend these meetings. If you do want to attend a meeting, please just reach out to any one of us on this list for information, and we will make sure that we can get you either a Zoom link or we usually have them at the PWGC, PW Grosser office. So we can get you that information if you do want to attend. So just please reach out to us. And then last here on the page or on the slide is that we do have a jobs posting page on our website. We are trying to get this page more action and traction. And if you do send us a job posting, we will post it. But just make sure that there is a contact information or a link to apply so that we can post that as well. Next slide. As far as upcoming events go, our Zoom and in-person quarterly dinner meetings are usually the 3rd Thursday of the month. So our next in-person dinner meeting is scheduled for Thursday, June 20th. Steve Panzer is going to present. He graciously offered to present a presentation on a remediation process that uses subsurface pulsing treatment technology. That event, you can register for it on our website right now. The event will be at the Marriott in Ronkonkoma. All that information should be posted, and we're currently looking for a bar sponsor for that one. So if you are interested in sponsoring a bar, please reach out to any of the board members for more information on that. I'm sure that those attending would be very appreciative of anybody that offered of that to us. We also have some save the dates posted for the kayak trip in the Hall of Gems, Museum of Natural History, Hall of Gems. So like I said before, that's up on the website. Once we get that closer to those events, we will open it for registration. And you should at that point also receive an email reminder. And then one just last event that's going to be coming up this year is the 2024 Geology Days Conference. That's November 11th through the 13th in Saratoga Springs. And it's offering around 12 continuing education credits or credit opportunities available through the different presentations that they will be making. So here is the usual appeal for speakers, and then I'll get into these other organizations. But I do want to say that each month it is really, truly the hardest thing for us to find speakers for these webinars and events. I think as licensed PGs, one of the requirements, well, I know as a licensed PG, one of the requirements to maintain that license is by making sure that we are current in our PDHs. So we hope that by offering, the LIAPG hopes that by offering these webinars, we are helping our members and our guests to fulfill the obligation to get those PDHs. But we can't offer these webinars and these events if we have no content. So with that said, as always, we are encouraging people to step up and volunteer to present. I know it sounds scary. If you don't like speaking in front of a group, and you can always volunteer for a webinar, which is a little bit easier, in my opinion. And providing those PDH credit hours is really an important function for this organization. So for all of us who are PGs, and again, with no content, we can't make that happen. So anybody who has any ideas or wants to step up and you know, even if you have a thought or an idea, or you're not really sure if an idea or, you know, what a presentation would be a good one, you know, just approach one of us and we can chat about it. We would really appreciate it. I cannot emphasize that enough. So with that said, some of the other organizations that we always like to remind people of are, there are a few throughout the New York State area. Obviously, we have the New York State Council of Professional Geologists. And then we have 3 regional organizations, the LIAPG, the Central New York Association, and the Hudson Mohawk Professional Association, covering, again, various locations throughout the state. There's also the NEA IPG and the PCB PG if you're looking for good content or presentations. All of these organizations do it, including us. Lastly, there is the Stony Brook Open Night Geology Lecture. I think their webinars typically offered in the spring and the fall. I think that their schedule has come to an end for this spring, but they do offer a schedule that they list on their website if you're interested in participating in that. We are doing something a little bit different or new. I'd like Chris Wenzel, who sits on the New York Council, to give a quick update on some relevant news that we should be aware of at the state level. So I'd like to turn this over to him and then we will get going with the presentation. Chris.
Thanks, Regina. Hello, everyone. I think most of you probably know me, former president of LIAPG, currently serving as vice president on the New York State Council. And we thought an update to disseminate information might be beneficial. Um, Regina already touched on Geology Days in November, and she's correct. It's going to be the third event. We have great content. We've got pretty much a full plate of abstracts submitted and papers, and the content is going to be varied, very varied, really interesting. I've seen most of it, and it's cool. Um, if you're seeking PDH credit or camaraderie along with your professional colleagues here, this is a good one. And I will tell you now that um, reservations with the discounted price that the council offers are open at the Saratoga Springs Holiday Inn where we host the event. So I would advise if you have any intentions of attending, make your reservations soon because you will get shut out. They only have so many rooms, and we're anticipating a larger crowd than before. Will probably be a capacity this year because it's been growing. Um, Secondarily, the um, third or fourth annual Geology Rocks event is planned tentatively for April of 25, and that occurs in White Plains. It's downstate here. We had a great event last month. The attendance was about 150 people. The venue is fantastic. York put really a big effort forth. They sponsored a party bus from the Melville's Park and Ride, and it was great. Great show, great band. I would encourage anyone to think about attending. It was my first time I had the opportunity to actually get there, and there were more people there that I knew than I really expected. So I had a great time. A little bit on regulatory. There is a new set of amendments to Part 375. There's some revisions that were published back in the New York State Register on 14th of February, and those revisions, there's many through it. The one that was kind of neat was it's going to make a formal recognition of professional geologists in there at this point, and that has an impact when it comes to the definition of qualified environmental professionals. If you're interested, get in touch with me. I can send you a link to both the register, which has a great synopsis of the changes to Part 375, or there's a link to a DEC website with a red line, which is pretty easy to look and scroll through. As far as things going in the political arena, in either the state senate or the assembly, there's a couple things going on. For professional licensure, there was a pathway that didn't necessarily require the heavy academic credentials that are required under the straight path. And that is if you have 12 years of experience and you can demonstrate it and get it accepted by the state education department, that was called the experience ladder pathway. There is now actually a bill in process to eliminate that pathway. So if you're an individual that qualifies and have any intention of applying, I would recommend that you apply sooner rather than later because there will be a grace period. But once that grace period ends, you'll be out of luck and you'll be, tasked with taking the ASBOG exam series if you wish to become a PG. There is also a grandfathering correction bill, which is related to when the law went into place for professional geologists. There's a number of engineering firms in New York that were what they call grandfathered engineering firms. And there's a requirement under the current regulations that any engineering firm that is a grandfathering firm has to obtain a certificate of authorization to practice professional geology in the state. Actually, I should say that differently. Any company that is going to do that needs to obtain a certificate of authorization, much like professional engineering. Um, and there were provisions originally in the bill for that to be covered under the grandfathering situation, but that's not how the law got passed, and it's recognized as a deficiency. So there is a bill that has just moved as of yesterday from the Senate to the Assembly. It may make it through the assembly without getting referred back to state education and make it to the governor's desk this year. There are, just for relevance here, in New York State, there's about 80 companies that have this issue where they are grandfathered engineering firms. But certainly, if you're interested, get in touch with me. I can direct you to websites and more information about it. And lastly, you will see, just like LIAPG, we depend on our membership, and you will see there will be a New York State Council membership drive in the coming months. And the benefits, just like being a member of the LIAPG, similarly being a member of the council, gives you a lot of advantages and benefits when it comes to like the cost of attending geology days and some of the other events. So that's the summary. Thank you for your time. Back to you, Regina.
Thanks, Chris. So with that, let's get to it. If you guys are seeking, you guys and gals are seeking PDH credits, and you paid for them, and I'm sure most of you know this already, but I'm going to go through the rules again. There are a few of them that need to be followed to satisfy the requirements of the state education department. First and foremost, you have to be here and you need to pay attention during the whole time. In Zoom, we do have a chat function. So if you are present and seeking those PDH credits and you did not do so already, you need to identify yourself by your name now. You need to use both your first and last name. If you are listed as iPhone or something similar, you need to write something like Regina Bycobb-iPhone, so that we know who you are and how to identify you. We do have a few quiz questions at the end of the presentation that you also need to answer in chat. The chat feature does go into a text file, and we do also, with that function, it documents when you join the call and when you leave the call. So with that, we can verify if you're present or if you leave, or when you signed on, if you're present for the entire time. So there are, like I said, it's be here for the entire time, answer those questions, get your name in the chat feature, so that we have record for anybody that needs a PDH. Again, thank you in advance for helping us to make sure that we're able to do this. If you have any questions during the presentation, you can type them into the chat feature and we will get to those at the end of the presentation. And with that, this is a presentation on PFAS in U.S. tap water. The presentation will provide a brief overview of the U.S. Geological Survey Environmental Health Program PFAS research, with an emphasis on its national reconnaissance designed to assess human exposures and potential effects of PFAS nationally in tap water collected at the point of use. It is presented by Kelly Smalling, thank you, who is a research hydrologist with the U.S. Geological Survey, New Jersey Water Science Center. She is co-lead along with Paul Bradley of the USGS Environmental Health Program, Drinking Water and Wastewater Infrastructure and Integrated Science Team. Kelly's research is focused on the actual versus perceived health risks of contaminant mixtures to human health and the environment, including fish and wildlife. Thank you, Kelly, for volunteering to present today. We really do appreciate it. And if everybody could please give her your attention, I think she is going to offer a very interesting talk. And with that said, I am just going to take a quick break here while I stop sharing and give Kelly the opportunity to share her screen, and then we will proceed.
All right. Thank you so much, Regina, for that wonderful introduction, and for Chris for inviting me tonight. And I'm excited to be talking to you guys today. I hope by the end of this presentation, you'll have learned a little bit more about PFAS and why the USGS does what we do in tap water. So I As Regina said, I am a co-lead for the drinking water and wastewater infrastructure integrated science team. It's a mouthful, so we just say infrastructure science team. But the goal of that team is really to understand the human impacted water cycle. So we focus on contaminant mixtures in drinking water, and we also have a secondary objective, which really focuses on contaminant mixtures in surface waters, particularly those derived from wastewater treatment plants, stormwater, really kind of diffuse pollution. And ultimately, when you think about our drinking water sources and our drinking water intakes and our local stream systems, kind of that water cycle is they're connected, particularly in areas where you've got surface water intakes. And PFAS is a big issue right now. It's been made a lot of waves in the press. So this was kind of the USGS's first really national look at PFAS. But before I talk about kind of our PFAS study, I want to give you more of an overview on kind of why we do what we do and, why we're focused on tap water. So I'm going to try to see if I can get this guy to go away. I can't. So anyway, in the US and also globally, the quality and the sustainability of drinking water, they're really growing challenges. And this tends to be due to increased water demand and contamination of drinking water resources. And currently, there are hundreds of thousands of different substances that are produced globally. The TSCA inventory says about 85,000. A paper that was published back in 2020 estimated about 350,000 chemicals produced globally. And then if you look at the CAS registry, that has over 100 million substances. And so what can make it into the environment can be extremely complex. And the problem is that complexity is kind of outpacing regulation. So currently that little orange dot in that circle kind of represents priority pollutants and what's actually being regulated. So the Safe Drinking Water Act has about 90 pollutants that are actually regulated. And then there's a variety of other pollutants that have benchmarks, human health related benchmarks, but they tend to be low. And so we know that there's complex mixtures of contaminants in the environment, and that those mixtures are a challenge to drinking water treatment technology, just because drinking water treatment, particularly for public supply, it's not designed to remove contaminants. It's designed to keep us safe from diseases like pathogens and things like cholera. So I'm sure this is not unfamiliar to folks, but it's just kind of a reminder, and it kind of just really enforces kind of how we design the study and why we're doing what we are doing in tap water. But so in the US, there are kind of these three distinct, what we call distribution pipelines for drinking water. And we know based on work that we've done, and others have done it as well, they all can be a route of exposure to kind of these complex contaminant mixtures. So first you have public water supplies, so community water supplies. These are regulated by EPA under the Safe Drinking Water Act, and they're all, for the most part, monitored prior to distribution. So at the treatment plant or at specific locations within that distribution system. There's bottled water, which is regulated by the FDA, and it's regulated as a foodstuff. They use most of the same regulatory parameters as the EPA, but the regulations and the monitoring is slightly different when you think about bottled water. And then the last distribution pipeline are private wells. Private wells in most states, they're rarely monitored and they're not regulated, which means that folks on private wells tend to have little to no information on their drinking water quality. And so we know that complex mixtures of contaminants are present in the environment. We also know that they're present in drinking water sources. And we also know that many of these make it through treatment, because ultimately treatment is not designed to remove the contaminants. So we are being exposed. But what we're being exposed to, kind of that's the question that we're trying to answer. In this country, we're also grappling with things like aging infrastructure. If you remember the lead problems in Flint, as well as these really high visibility water quality failures like algal blooms in the Great Lakes, as well as PFAS exposure. And these are all leading to the public to ask if their tap water really is safe. So these factors, as well as other factors like increasing dependence on water reuse, and then that limited monitoring of private well water, as well as new research by public health researchers that are linking human health outcomes with really low level contaminant exposure. And these all are contributing to concerns over the safety of our drinking water here and globally. So these concerns have led public health agencies to come to the USGS. We are the science agency of the federal government, and ask specifically for information on contaminant exposure at the point of use. So at the tap, where that exposure actually occurs. So not at the drinking water treatment plant, not in a groundwater well, from your kitchen sink, from your faucet, where you're actually filling your glass. And they've also asked us to include what we call this expanded analytical toolbox. So instead of just focusing on, 90 or so regulated contaminants, I'll show you here in a minute, we have a robust list of contaminants, both regulated and non-regulated, that we analyze for in our sample. And it includes PFAS, and we've been working on PFAS since about 2016. But in order to understand this exposure broadly, so to think about kind of exposure nationally, as well as at the local scale, we tend to work with communities. So much of our work is very community-based, it's very community-focused, and it's community-led. And most of the work that we do, it supports individuals. So we give information back to the individual homeowners where we've collected that water. It also supports communities that are concerned about their drinking water quality. It gives information to state agencies, other federal agencies, as well as tribal nations. So we're providing information on drinking water quality at the tap. But because the USGS, we don't have a specific public health mandate. So we rely on these huge multi-institution research collaborators with other federal agencies that do have a health mandate, like NIH, regulatory agencies like EPA, as well as a variety of public health researchers and cohorts. So we're starting to expand to work with things like the Strong Heart Study, which is a cohort of Native Americans, the rural cohort, which is a rural community study in the South. So we're really starting to expand that portfolio so we're able to provide the information. So what we do is we provide the exposure data, and then we work with these health researchers to really explore the health outcomes. And then we work with our communities to facilitate discussions and to return results to the homeowners. So this kind of gives you an idea of our analytical toolbox. So to really understand human exposure through drinking water, we know that there's so many more chemicals out there than what we're measuring right now, but this is a start. So this toolbox includes, again, regulated and unregulated contaminants. So right now we have over 500 organics, and the list is here. We have cyanotoxins, which are from algal blooms, disinfection byproducts, which tend to be produced during disinfection in public water supplies, but there are some natural disinfection byproducts, PFAS, pesticides like atrazine, glyphosate, things that you apply to your yards, things that we apply to our pets, and as well as things that we apply to foodstuffs. Pharmaceuticals, mostly human use pharmaceuticals, and then certain things like volatile organic compounds like PCE, which are actually one of the most regulated group of compounds on this list. We also do about 34 inorganic chemicals like arsenic, lead, uranium, things that some that are geogenic, others that are can show up in premise plumbing like lead. We have a suite of microorganisms, and then we do a series of bioassays. So they're in vitro bioassays that kind of give us an idea of potential activity, so potential for human effects. So we've been developing this information on drinking water exposures in a range of settings across the nation, which you can kind of see here from the timeline. We're working in tribal communities, we're working in underserved and underinformed communities, and our project is national in scope. We are a national research team, but because we're a small team and we don't have a ton of funding each year, so what we do is our studies are conducted modularly. So we kind of move from community to community with these spatially specific pilot studies that are, again, really geared to specific community needs. But we have the same team, we collect the same constituents, we do the same amount of quality assurance. So that allows us to actually take all the data and then roll it up to answer kind of these national questions like PFAS exposure. So what this timeline is showing you is kind of our drinking water trajectory. We started small in 2016 with a national pilot just to kind of understand if this was an issue. It was, and we've kind of moved along from there. We spent a lot of time in Chicago. We've done work in both public supply, private wells. 2020 was COVID. We couldn't get out into the field. So because we couldn't get out into the field, we decided to do a bottled water study. We didn't need anybody to do that. We just needed a bunch of bottles. So we did that bottled water study in 2020. And then our PFAS recon, which I'm going to move into next, we started that in 2021. And we finally published that in 2023. So on to PFAS. I'll go through this relatively quickly because I think that most folks have a good handle on PFAS, but it's good to kind of get a little refresher. So first of all, PFAS issues in drinking water and those associated public health effects, they've really been driving the public narrative over the last few years. The public and their concerns have really been pushing kind of the regulation and the speed at which things are happening in the regulatory community related to PFAS. So it's been actually really interesting to watch. PFAS are not new. They've been manufactured and used in a variety of industries in the US since the 40s. So this keeps changing. When I first put this talk together, it was a unique class, had over 12,000 unique compounds. I believe we're up to 15,000 unique compounds. So we are only able to analyze a very small fraction of PFAS that are could be out in the environment. The interesting thing about PFAS is that they're highly, highly fluorinated and they're 100% man-made. There's nothing natural about a PFAS. And due to their chemical structure, they're resistant to heat, water, oil, which is fantastic as a consumer product. Like you want something that is resistant, particularly like your rain gear, your fast food packaging. But because they're so resistant, it means that they're ridiculously persistent in the environment as well as the human body. I'm pretty sure a recent study just came out that said 96 to 97% of the people had PFAS in their blood, which again is not surprising. It's been around since the 40s. Again, PFAS have been found in the human plasma. They can be maternally transferred, both pre and postnatal. And then more recent studies have begun to link PFAS exposure to metabolic and immune disorders, as well as certain types of cancers. So this has really been driving the narrative on PFAS is the human implications. So at this point, we can find PFAS in almost everything. So this, first of all, I'm going to show this map again later, but this map is basically our sampling locations. But under that, we basically turned the entire US into a hexagon of PFAS sources using information from EPA. So the darker the hexagon, the more sources. So I think some of these really dark ones, they have over 2,000 potential sources in a 1,500 kilometer square hexagon. So that's a lot of potential sources. We heard about them in aqueous film forming foams. So foams to treat fires, like fires on military installations and at airports. So really hot fires, not forest fires. They're in stain resistant and water resistant products, paints, cookwares. They're in packaging. They've been shown to be in the coating inside pesticide containers. So they're making it out into the environment during aerial application. And then specific sources, again, there's a lot of them. Industrial sources, manufacturing facilities, airports, military installation, oil and gas extraction, as well as wastewater, landfills. I could go on. And it's also important when you think about from a human perspective, it's not just drinking water. So because PFAS are everywhere in the environment, they're in the water, they're in your surface water, they're in your groundwater, they're in your soil, they're in your rainwater. And there's just at this point kind of like a natural background concentration of PFAS that we're trying to understand. They're also in biosolids, so they're in the food that you eat. So the bottom line, I think, which I don't know if it's depressing, but PFAS is everywhere. So we kind of can't get away from it at this point. So what did we do? As I said at the beginning, and when we first started this, there was really very little information on PFAS at the point of use. So in the tap. And most of the drinking water studies, whether they were state or EPA's Uncontaminated Monitoring Rule 3 and 5, which just started, but those are sampling at the distribution system with little regard for private wells. There are some states that do have private well testing for PFAS, but ultimately the knowledge on PFAS at the tap is very limited. So to better understand human exposure at the tap, we conducted this national survey using a network of volunteers, citizen science, whatever you want to call it. We got volunteers and we shipped kits and they shipped it back to us and we analyzed their samples for PFAS and then we gave them their results. We had a return rate of about 90-ish%. So we got about 90% of the kits that we shipped back. All in all, we shipped over 400 kits out. And then we took those 400 kits and then we combined that information with data that we had collected previously as part of our other drinking water studies. So all in all, we had 716 samples. We had samples from every single state. So all 50 states, the District of Columbia, Puerto Rico, and the US Virgin Islands. So we don't have detailed samples in every state. We have, between 4 and 12. So it's not going to give you a really good estimate on a state level, but it does give you kind of this broad brushed understanding of PFAS. At the end of the day, we had 447 samples from public supply and 269 private well locations. This may not seem like a huge data set, but for an organic chemist, where these cost upwards of like $700-ish a sample, this is a lot of data, and we were really excited to work with it. So there's a map again. We also, again, like I said, we gridded the entire country or hexagoned it. And we use this to kind of understand potential drivers of PFAS contamination. So we compiled this information from their PFAS analytical tool. They have an ECHO database. And this kind of just gives you an idea of what kind of sources or what the breadth of the sources look like. Those gray areas kind of over here and over here, there's just no potential sources. So there are areas of the country where we don't have any PFAS sources. And then in our analysis, we calculated distance to nearest PFAS source, number of potential PFAS sources in a 5-kilometer hexagon around our site. And then we also looked at the types of sources as well as land use, kind of all as predictor variables. And this map is again showing our sites. So private wells are the green triangles, and then your public supply are your circles. So as you can see, we've got quite a bit of data from the Northeast, because that is where I am located. So now jumping into some of the results. I think that was enough of a big overview. And this is kind of the meat of the paper and the study. So what this map is showing you is basically where we detected PFAS and where we did not. So anything that's colored, there was at least one PFAS detected, and anything that is not colored, there were no PFAS detected above our reporting limits. Again, those circles are the public supply and the triangles are the private wells. Based on our data, at least one PFAS was observed in 30% of the tap water samples collected across the US. We had very few detections in Hawaii. Actually, we had no detections in Hawaii. And we had very few detections in the arid West and the Northwest. You can see a lot of non-detects in the West. We didn't have as many samples in those areas as we had in some places like the Northeast or in the Great Lakes region. So this is an area that we'd like to kind of expand some of our sampling, but this just kind of gives you an idea. There are areas of the US where PFAS just was not detected. So this is another way to look at the data. So instead of showing detections, now I'm showing concentrations. And so the white circles are those non-detects, and this includes public and private together. We're not distinguishing them. So the open circles, there are no PFAS, and then the larger, the darker the circle, the greater the concentrations. So concentrations range from less than 1 all the way up to 300 nanograms per liter, or greater than 300 nanograms per liter, again, depending on location. So what this is starting to show you is kind of some of these hot spots for PFAS contamination, like areas in the Northeast, areas in kind of some of the Great Lakes. California has quite a few PFAS. We have a couple of odd detections in Florida and, other random spots in the Midwest, but you can kind of see where these hot spots start to jump out at you. So this is just kind of a graphic of temporal changes in PFAS. So typically our tap water studies, they include a one-time sample. We go in, we collect the sample, and we leave. And it doesn't provide any information on how concentrations change over time. So we were doing this recon, we were sending out kits. Of course, I analyzed my own house, as did a couple of colleagues of mine. So if we're going to analyze them once, we might as well analyze them quite a few times. So we decided to collect samples over time at 3 locations. 2 were private wells and 1 was a public supply. There was 1 private well in South Carolina, which is not shown here because that well did not have any PFAS. What's shown here is a private well in the orange and a public supply in the blue from New Jersey. both clearly with detectable PFAS, and we'll talk about the MCLs later, but they're above the MCLs for certain contaminants. And what you can see here is, this is a small scale, so it's between 0 and 25. It looks like PFAS is the concentrations are kind of bouncing around. This is a total PFAS, so it's the sum of everything that we detected. But for a lot of these compounds, they're really close to our detection limits. So sometimes they just kind of pop in and then pop out. So if you were to kind of draw a straight line across here, there's not a whole heck of a lot of difference across this. You may have some variation, but you're not at 20 and then at 0, or at 50 and then at 20. Your range is staying pretty consistent over time. So because one of these is my house, which is the orange one, I actually installed a sink filter, a carbon filter on my sink to get rid of these things, and it did. And then I measured it afterwards, and it did actually remove the PFAS from my sample. Clearly, you have to keep those. You have to change those relatively regularly. But New Jersey's also one of the only states with a private well testing act that actually requires us to test our wells prior to sale. And then actually recently, PFAS were added to the Private Well Testing Act. So this information is actually valuable. New Jersey's building a database of private well PFAS data, which is fantastic. And other states are kind of doing some similar things, particularly with private wells. So I think as kind of the years go by, we are going to see more of this kind of information in private wells. So the last couple slides were the actual data. And then we applied some fancy Bayesian models, which I couldn't even begin to explain because I'm not a Bayesian modeler. But the point is that what we wanted to do was take the information that we had and try to, one, understand kind of drivers of contamination from a source perspective. But then we really wanted to try to predict more broadly into areas where we didn't sample. So into kind of unmonitored or unsampled location. And also to understand on a national scale how PFAS compared between private wells and public supply, since we tend to have more data in public supply. So we had three fancy models. The first model looked at individual PFAS concentrations. So we picked a select group of PFAS that were detected in greater than, I think, 5% of the samples. And that's what we included in our model. We also took all of the total PFAS concentration. So we added up all PFAS, and we modeled total PFAS concentration in private wells and public supply. And then we were also interested in understanding, was there a difference in the number of PFAS observed between those two distribution pipelines? So instead of showing a boring graph, I decided to show some water droplets it's just a cartoon representing our data. If you want to see the real graph, you can take a look at the paper. But what this is showing you right here, the water drops are almost on top of each other. So what this is showing us is that for total PFAS, it was the exact same for number of PFAS as well as for individual PFAS compounds. There was no difference in concentrations between public supply and private well tap waters. So the droplets are the median concentration, and those little arms that are going out are the 95% confidence intervals or credible intervals. The medians are on top of each other, and the credible intervals overlap. So we're not seeing any difference. So why does this matter? Why is this important to kind of understand? So for us, what this is helping us tell people is that if you're a private well user and you have no information on your drinking water quality and you're really potentially concerned about PFAS in your well, but you don't know if you should go test it, you could take information from your public supply in your area, particularly if it's coming from groundwater. And you could use that data to kind of assess whether it makes sense for you to do something about your well. This is not a one-to-one relationship. This is probably going to be debunked when you look at specific community data or regional data, but it's a start. And it's a start for private well users. So it's just giving them some information to help them understand if they want to take preventative action, or if they want to test, or if they want to reach out to their state public health agencies or departments of environmental protection about their water. So again, it's not the end all be all, but it is a start specifically for private well users. We also used our entire data set. Again, I'm excited about 716 samples to estimate the probability of detecting few PFAS or a lot of PFAS. So between 1 and 10 PFAS in taps broadly across the US. So based on these model predictions, on average, about 45% of US tap water contains at least one PFAS. Again, with no differences on whether or not you're in a private well or public supply. Also, the taps, as you can see from the graph here on the right, the probability of detecting 1 to 2 PFAS is much higher than 9 or 10. So 1 to 2, you're upwards of about a 20% probability, but down around 9 or 10, you're less than 1%. So we had very few houses that had a large suite of PFAS. They typically had between 1 and 3. Our models also predicted that the probability of, now we're going to not detecting a PFAS in tap water, ranged from 25% in urban centers like Chicago, or areas with known PFAS contamination like Cape Cod, to greater than 75% in rural areas. So based on the information that we kind of hear in the media and, reading online, we tend to assume that PFAS is everywhere. But as you saw from kind of our maps of sources, as well as our data and our model data, there are portions of the country that do not appear at this point to have a PFAS problem, which it's a good thing. So PFAS is regulated now. The first ever and final PFAS regulations were recently released last month. And so this table gives you an idea of what they are. So we have 5 PFAS that are actually being regulated. So the maximum contaminant level is your regulation. That's on the far right. So for PFOA and PFOS, you're down at 4 nanograms per liter. And for the other 3, the MCL is 10 nanograms per liter. However, with MCLs, EPA also releases a maximum contaminant level goal. These are non-enforceable health goals, but they're established to protect vulnerable subpopulations like infants, children, and the elderly. So any contaminant that is considered a likely or known carcinogen typically is given an MCLG of 0. PFOA and PFOS both have an MCLG of 0. So for your vulnerable subpopulations, what that means is there's no known safe level of those 2 PFAS. What's also exciting for folks that have been following regulations is that PFAS is actually the first class of chemicals where EPA is actually regulating for a mixture. Typically, EPA regulates one compound at a time, and they don't really think about interactions of mixtures, and we know things occur in mixtures. So what they're doing is they're taking this hazard index approach, which you can see here on the screen. It's basically made up of a sum of fractions. So what they do is they take the drinking water concentration in the numerator, and then they divide by that health benchmark, which varies based on PFAS compound. And then they divide it, they add them all up. If it's greater than or equal to 1, you have an MCL violation, but you have to have 2 or more of these. So if you just have PFBS and that's it, then it's not going to be an MCL violation. So how does our data actually compare to the new PFAS regulations? Back when we released this paper, these were still proposed, but now they actually haven't changed, which is great. So I haven't had to update this graph. When you look at all 716 samples, we had a 30% detection rate for PFAS. So PFOA and PFOS, they were exceeded in less than 7% of the tap water when you think of all samples that were collected. But if you just look at the taps where they were actually detected, then PFOA was exceeded in 48% of those taps where it was detected, and PFOS was exceeded in 70% of the taps where it was detected. And you can see that here on the graph on the right. That red line is that 4 nanogram per liter MCL. The median for PFOS is above that. The median for PFOA is kind of right on that line. So we are seeing quite a few exceedances when these compounds were detected. We also compared our data across the hazard index, and we had a hazard index exceedance of 1, so another MCL violation in roughly about 5% of our tap water samples. So comparing to MCLs is great, and comparing to MCLGs is even better, but there's quite a few PFAS beyond those 5 that actually have human health benchmarks, whether they're by states. So states have quite a few human health benchmarks for other PFAS. So the public health community is interested in exposure to everything or to all PFAS. So because we have this history of working with the public health community, and they really have a desire for information on real world contaminant mixtures, is really what they value. So to support these communities and these researchers, we need to take our exposure data and translate it into a measure of potential risk to human health. So beyond just, does it exceed an MCL or not? So similar to that hazard index approach, we've been doing something similar. We take that exposure concentration, divide it by the benchmark, add it all up across all PFAS, and we get what we call a sum toxicity quotient. So the toxicity quotient tends to be a conservative estimate because it's limited by available benchmarks. It's better than just comparing straight to an MCL, but it is limited based on our analytical capabilities and the PFAS that actually have benchmarks. But it can really be utilized effectively to frame our exposure data for public health agencies as well as communities. So this is kind of what a typical toxicity quotient plot looks like. It tends to look like a bar plot. And we've got private wells in the blue and public supply in the white. So now I have a red line here and a dotted yellow or orange line. So basically what this is telling you is if you have a total toxicity quotient, so a sum TQ similar to the hazard index, if that is greater than 1, there's a risk to human health in that drinking water sample. If it's between 1 and 0.1, there's the potential. And if it's less than 0.1, we consider that not to have a risk to human health. So from our screening assessments, this just includes the samples in which PFAS were detected. That sum TQ of 1 was exceeded in 52% of the tap water samples. And this indicates a high an elevated probability of aggregated risk when considering, again, PFAS with available benchmarks. And as expected, so given their proposed MCLGs of 0, a lot of these sum TQ results were driven by PFOA and PFOS when they were detected. So in our study, about 23% of the tap water where PFAS were detected were below 1 and then considered no risk. So overall, what these results indicate is that there really is a potential for human health effects for PFAS through drinking water. And they're common and they tend to be relatively comparable in private wells and public supply, although our public supply tended to have more samples exceeding that sum TQ of 1. So I've just thrown a ton of information at you, and I'm hoping that some of this did stick. But kind of to close, before I wanted to show kind of a couple of geo narratives that we have, but a few takeaways from this paper and from this study. So the first thing that I want you to remember, or I'm going to tell you because I don't think I told you this at the beginning, approximately 40 million people in the US rely on private wells for drinking water. And again, as I mentioned at the beginning, they're rarely monitored. And then until recently, most of these national testing programs really focused on public water supplies that served greater than 10,000 consumers and did not capture information from rural communities. And rural communities really did not have information because they couldn't afford to sample for PFAS. And that makes up about 52 million people. So that's a big chunk of the population. And these small public supplies and private wells, they may actually be disproportionately affected by PFAS, which emphasizes the value of this study, which really focuses on private wells. And we did try to collect samples from some of these more rural areas where information is not available. Based on our models, an estimated 45% of tap water, US tap water, may be contaminated with at least 1 PFAS. As more data becomes available, this number we will be able to improve this estimate. Again, we didn't see any differences in public and private supplies. Results also indicated that detection probabilities varied spatially. There are areas where PFAS just was not detected. I didn't spend a lot of time talking about this, but geospatial data like land use, number of sources, distance to source, they can all be important predictors of PFAS. So they can kind of help folks understand potentially vulnerable areas. And then lastly, the exposure and potential for human health effects from PFAS, they're common. They tend to be relatively comparable in private wells and public supply tap water broadly across the US. So we collected a lot of information. We gave this information to homeowners, but we also wanted to develop this kind of public-facing dashboard, which will allow folks to explore the data. So this dashboard, it is current, it's up to date. As more data becomes available, we are going to update it. And so I think we have a little bit of time. So I'm going to try this. I don't think I've ever done this before, but I want to try and see if I can bring up the dashboard and just kind of give you, if you haven't seen it, just give you an idea of what it looks like. And we actually did a neat little video on this too, on how to navigate it. But it gives you some instructions. We have kind of all the information. We have the paper. We have our data releases. So this is our kind of raw data. We have information on where to find us. But what you see when you zoom in, I'm assuming this is working.
Yes, we can see it.
Okay, good. Thank you. What you can see when you zoom in is you can kind of see that base map that I showed, but now you can interact with it. And so you see, we have circles, we have the hexagons that have PFAS sources. So you can click on this. Let's see if it'll work. You can, well, wow, what's it doing? All right, so you can click on that source, the circle right there, and this is telling you this is a private well in New York. What it's telling you is that the total PFAS concentration was 71 nanograms per liter, and these were all of the PFAS that were detected. And then you can do something similar. You can click on one of these hexagons, and it'll tell you how many facilities are in that hexagon. You can toggle back and forth. You could turn off the sources because that gets a little gnarly to look at. And then if you wanted to zoom in, you can zoom in on a point up to a point. But because these are private, personal, these are homes, we don't want to give away private information. So once you get to a major road, we basically pin it to a road, and once you get in there, you can't get to the exact location. And the reason we pinned this to a road is because in the city, like there could be a boatload of houses around that point, but when you get into places like rural Iowa, middle of nowhere, Montana, there could be one house. So we didn't want to kind of identify that house. So that's the dashboard. This QR code will take you to the dashboard if you're interested. The last thing that I want to point out is we also have what we call our drop-by-drop geonarrative. This is another tool that kind of gives folks an overview of our entire research portfolio, so in all of our tap water studies. And it also includes an interactive map that shows results by study area and chemical class. And again, we cross-post on each one so you can get to each one. And that's the QR code that will take you to that one. And so what I want to leave you with before I open it up for questions is that this is it's not that old, but it's still the most comprehensive study on PFAS nationally at the tap. Again, where people fill their glasses. It will provide and continues to provide information broadly to local and state public health agencies, decision makers, regulators, and it gives private well users some information, particularly in areas where PFAS exposure and then that potential risk is high. So with that, I am going to attempt to stop sharing and open it up for questions.
Actually, I think before. I'm sorry. Before we actually get into questions, I think we want to do the 3 presenter questions.
Well, I don't have any.
Okay, Regina, do you have those?
Regina does.
I have those. Yes, I'm going to share my screen now. Let's see if I can get this going. Can everybody see this?
I don't see anything yet.
You don't see
Not yet.
Okay.
Not yet.
How about now?
Yes.
All right, excellent. Okay, so everybody please type your answer into the chat feature. First question is, PFAS has been detected in blank. A, public water supplies. B, bottled water. C, private wells. Or D, all of the above. I think most people are answering D. Kelly, what do you think?
It is D.
All right. Second question, how many PFAS compounds are known to exist? 21 compounds, 40 compounds, 500 compounds, or more than 12,000 compounds? All right. It looks like most people, if not all, are answering D.
That is correct. I wish it were 21 or 40. That would be a lot easier to deal with.
I'm glad everybody is paying attention.
Yeah, this is great.
We're 100% so far. And the last question, an estimated blank of US tap water contains at least one PFAS. Is it 10%, 25%, 45%, or 75%? So it looks like most people are answering C, 45%.
Yep, that is correct.
It looks like we all got 100% on this
Well
quiz.
done.
Very good. Very good. All right. So with that, Jen, you have the chat open.
Yes.
Are there questions?
Yeah. Actually, do we want to go to, I think Chris had one more thing he
Oh,
wanted to
yes,
add?
Chris, you wanted to add in some more information.
Oh, sure. Yeah. Just that when I was speaking about the revisions to New York State Part 375, I failed to mention an important point that I wanted to say was that the public comment period is open, but it closes next week on the 21st. And so the state does not offer a timeline for when they'll complete their review of public commentary and, finalize the revisions. But if you have an interest in reviewing those changes and have the desire to provide comment, you need to do that within the next 5 days. Tuesday it closes. That was it.
Thanks, Chris. All right. We do already have one question, but if anybody else has a question, please place it in the chat box, or you can feel free to unmute yourself and ask it verbally. We had a question earlier on in the presentation from Amy Marie Accardi Day. I believe this was relating to sending sampling kits to residences. How did you control false positives in the bottles? Not everyone knows how to properly sample for PFAS. You also need a rinse blank and a trip blank. Without the QC samples, your field samples may be bias high.
So that's a great question and a great point. I did not talk about QA in the presentation. I didn't want to get into the weeds, but we actually blanked all of our kits prior to shipping them out. We blanked our bottles, we blanked our tubes, we blanked our entire kits, and then we shipped out over 400 kits. We shipped out over 50 blanks to random participants, trip blanks, field blanks, whatever you want to call them. And we had only one PFAS detected in all of our samples. And we've also done over a couple hundred blanks with our regular tap water sampling, and we do not detect PFAS in any of our equipment at all.
Okay, that's great. We have a question from Derek Erzbach. What analytical method was used for the analysis?
So the USGS, we currently have our own method. So we use the USGS method. The details of the method are in the paper. There's 34 PFAS compounds that are analyzed. Detection limits are slightly higher than the new EPA 1633, just because this method was developed back when the health benchmarks were 70 nanograms per liter for PFOA and PFOS. Our lab is currently working on a low sensitivity method that gets us in line or lower than 1633.
Would you expect significantly different results between the EPA method and the USGS method?
The method is different. We're doing, I believe, 1633, and the EPA methods do an extraction. We're doing a direct aqueous injection. So the methods are slightly different. The reporting limits for the new one, the lower sensitivity would be in line with 1633.
Okay, thank you. From Soul Ash, in the graph showing tap sampling at your house, did the slope of the line flatten after or before you installed the filter?
So every single sample that was shown on that graph was prior to filter installation. So we collected for about 3 months. I wish I'd had the data back immediately, but did not have that data back until, it takes a couple of months to get that data back. So once that data came back and it showed elevated concentrations, particularly of PFOA, well above the new MCL, I did install a carbon filter on my sink and collected a second sample post-filtration, and the PFAS was removed and or below the detection limit. You can't ever say it's 0, but it was below the detection limit. So it was less than what we were seeing before.
It's actually on a similar theme. Albert Kim asked if typical retail water filters are effective in removing PFAS. And I guess I'll add on to that a little bit. Are there certain things that you need to look for on those retail filters to have a better feeling that they're going to filter?
So EPA actually has a lot of great information on filters. I can find that and send it and or put it in the chat if I can find it before this is over. But they give you a really good breakdown on which filters are effective. And they also cite a couple of studies that have actually looked at filters and how effective they are. But yes, I'm using a over-the-counter retail filter at this point. We're thinking about a whole house filtration system, but right now, as kind of a temporary fix, I am using a retail filter.
Okay, we have a question from Ivy Olberding. Were there any locations where you were surprised with the results, either negative or positive?
That is a really good question, and it's thought-provoking. I think, because a lot of the data came back before we got the sourcing information together. But, when a lot of people talk about PFAS, they just assume that we're going to find it wherever we look. But the fact that, we had big chunks of the country where, a lot of these areas are rural. But, there are areas of the country where we were not detecting PFAS. So that, I don't think that was surprising to me, but it was definitely nice to see. And then, some of the areas, there was a big PFAS detection in one, I believe it was a private well in Florida. Like I can't, sometimes you just can't explain that one sample. And, I think what this study does is it gives you an idea of areas of the country where maybe you want to do some more exploratory analysis. But that's a great question. I wish I had a better answer.
There's always more time and money for another study.
Yeah, does anybody have some? That would be great.
All right, we have another question from Elizabeth Limbrick. Any correlation between PFAS detections, concentrations, and the depths of the aquifer? For example, are more PFAS detected in more shallow aquifers or in more permeable aquifers?
That's a really great question, and I love that. I can answer it, but not from this study. We did not collect that information. We thought it was enough just to ask a homeowner to collect a sample. So we didn't really collect any information besides whether or not they were on a private well or a public supply. For the public supply samples, I don't even know where they get their water from, which was actually good when talking to the news media about this. So it was good deniability because I had no idea. But to answer your question, based on other work by the USGS, shallower, newer groundwater has more PFAS.
I'm sorry, you said shallower water has more. Yeah, okay.
Yep. So, the deeper aquifers with the older groundwater have less PFAS. PFAS has been correlated with tritium concentrations. So what the assumption is that you need that shallower, newer groundwater to actually see the PFAS signature.
Okay. We have a question from, I don't know what your actual full name is, but it's Destafanis. I'm sorry, you may have said, were all of the public tap samples from groundwater sources, or were there surface water sources included?
No, it was a mixture of surface water and groundwater sources. For the subset of samples that we collected previously, we know exactly what percentage was from surface water versus groundwater. But again, from the 400 or so kits that we sent out, I have absolutely no idea what their source water type was.
Okay, does anybody else have any questions? Again, please feel free to also unmute yourself to ask if you'd like to.
I'd actually like to ask a question. You just, Kelly, you just said that PFAS is associated with tritium concentrations.
Mm-hmm.
Can you expand on that, or?
Yeah, so kind of. I'll do my best. There's probably somebody in the room that's way more knowledgeable, so if I flub this, I apologize. So tritium is a really good indicator of 1950s and beyond. So tritium, wasn't that from the atomic bombs or something?
It's like a water with one extra hydrogen.
Yeah, right.
You're
Yeah,
right.
I
I don't
know
want to say it
what
like
tritium
that,
is, but yeah, so it represents newer things that are going on in the world. I guess that's the best way to say it. So tritium is representative of processes that occurred from 1950s and beyond. So I think it has to do with, man, I'm flubbing this big time. Is anybody gonna rescue me?
Oh, you're doing good.
I
Thank
can
you.
add to
That's
that
what I was
in that
looking for.
in that
Anthropogenic was
Chris
one
is
of them.
stepping
Go,
in.
Chris.
Here you go.
Rescue.
our atmosphere was enriched with tritium once we detonated the first atomic bomb.
So I
And
was
then the
on the
testing
right
that
track.
occurred in the 50s is contemporaneous with the beginnings of manufacture of PFAS in the late 50s, which then continued into the 60s when it was originally the predominant use was for making firefighting foams for the Air Force. And so when you look at groundwater, you can see if you see tritium and you see PFAS in the same data set, it represents a newer, fresher contribution of atmospheric water to the aquifer system. I'll say it that way.
That was much more eloquent. I was on the right track, though. Thank you.
Okay, are there any other questions? Sonia Ward just posted the info from EPA on tritium. So if you are more interested in that, the link is in the chat. We have another question from Lori Williams. Did surface water typically have more or less PFAS than groundwater wells?
From this study, I don't know. Again, we didn't collect that information. We do have other studies where we've looked at surface water sources of drinking water and compared them to groundwater sources. This was in Minnesota, and groundwater sources tended to have more PFAS and higher concentrations than surface water sources in Minnesota. But I know other folks have looked at that, but we did not look at that in this study. But that's a good question.
Hey, this was actually a question that was sent directly to me, but does anybody have a link to the USGS PFAS dashboard that they could post into the chat?
I do.
Okay, thank you. Right, any other questions? Last call?
Oops, I sent that to Bob Moser. I apologize.
He was actually the one asking for it.
So. Oh, really? Okay.
Yes.
Excellent.
But I'm sure everybody would want it as well. Okay, we have another question from Albert Kim. Are there any plans on extensive soil testing?
Well, that would be great. I know I do have a colleague in New Hampshire that is actually just completed a reconnaissance across the state of New Hampshire of soil sampling. So she does have that data. And I think she's working with the state on helping them with their regulation for this. But other than that, I don't know of detailed soil testing. I think it would be pretty interesting. Again, it gets back to kind of, as Chris mentioned, these things have been around since the 40s and 50s. They are and they're persistent. So kind of understanding now what that background concentration of PFAS is in soils would actually be really interesting. So somebody needs to do that.
One of my coworkers was in a meeting or a conference with it's either Beacon or the New York City Brownfield Partnership within the last month. And I believe they said that New York was looking at doing a background soil study, but mostly in upstate New York.
Cool. That's
I don't know if
great.
anybody else has more details on that they could share.
Jen, you're correct. They are contemplating that, when New York State has been pretty progressive in understanding the extent of PFAS impacts in the environment. And, they started with some really high profile sites where it got the public's attention. So the first thing to do was to sample groundwater and drinking water supplies, easy, accessible, very less expensive than soil sampling. So that was the initiation of it, where they actually, went to all the inactive hazardous waste site registry sites and reopened and required sampling there. And then it extended to EPA Superfund sites in New York. And I'm actually going through a situation now where beyond the groundwater sampling, the EPA is getting concerned about soil, but that's a different topic for a different day. But I will tell you that soil impacts tend to be mostly caused by air, PFAS air emissions or PFAS in air emissions, dispersion, and soil deposition, which creates a footprint and then continues on to leach to groundwater. So there's a whole series of events that occur there.
Yeah, I see that there's other states that are starting to do soil testing. And I think that's, in my scientific opinion, I think that's probably the next step. We've got a really decent handle in a lot of states on groundwater contamination and surface water contamination. I think, Chris, I think you're right. I mean, the next thing is really starting to address that soil contamination.
Right. Yes. Andy Lockwood, he mentioned that Vermont and Massachusetts have also completed statewide soil background studies.
And if you Google PFAS in food, you'll find in Europe, the Europeans are way ahead of us in looking at PFAS in chickens, eggs, livestock, particularly pork. There's some really interesting studies out there that it's surprising in that, things like chicken feed typically were found to have PFAS in them. The interesting part was that, when you took the chickens off of the tainted chicken feed, their eggs cleaned up after about a month to 8 weeks. But there's a lot of interesting studies out there that really make you raise your eyebrows and go, huh, didn't know that.
Yeah, we're working on a study with deer. So a deer study to try to understand what exposure looks like through deer and a variety of other animals. But that's kind of, it's not livestock, but they're not getting it from biosolid application and being taken up through the crops, but definitely is another route of exposure.
All right, I think that's probably the rest of the questions. Regina, do you want to close us out?
I would love to. Yes. Thank you, Kelly. This is great. Thank you for volunteering and taking the time to do this. Really appreciate it. And thank you for everybody being here. And we will see you hopefully on June 20th at our in-person meeting at the Marriott in Ronkonkoma.
Thank you all very much. It was a lot of fun. I appreciate it. This is a great group.
Thank you, Kelly.
Everyone have a great night.
Bye.
Bye.